2009,
What
number
kind of
one
name's
with
Karen
a
with a
TI.
K?
All right, so Karen with a C is riding her bike along a road. For part A, find the acceleration of the bicycle. You are given velocity, acceleration is the slope because we want the derivative of this graph. At 7.5, I want the slope of that line segment. It's clearly negative because it's going down. I'm going down 0.1 over 1. So for part A, acceleration at 7.5 is negative 0.1 miles per minute squared. Be careful, I had a problem with the units on the y-axis, so watch out for that. Part B says, using correct units, explain the meaning of this integral. If you recall, when we integrate the absolute value of velocity, that gives us the total distance that she travels. So it's the total distance traveled. So that's what I'm explaining here. Total distance Karen rode from 0 to 12 minutes, and that's measured in miles. And now we actually have to calculate it. So you want to find the area of every, I broke the graph up into triangles and rectangles and trapezoids and found the area of all the different little sections to get a total of 1.8 miles. Again, be very careful with your units on that y-axis, okay? So that's part B. Now part C says, shortly after leaving home, she realizes she left her calculus homework at home and returns to get it. At what time does she turn around and go back home? Give a reason. So if you look at this, we are checking out part, you want to see when velocity changes sign, because when velocity changes sign, that means a change in direction. So at 2 minutes, velocity changes from positive to negative, and that signifies your change in direction. So I'm just explaining that. And then finally, part D. Larry also rides his bike along a straight road from home to school in 12 minutes. His velocity is given as W of t, this function, where W is miles per minute. Okay, who lives closer to school, Karen or Larry, and show the work? Well, here's what you have to be careful of. To find the distance that Larry is from school, you want to integrate from 0 to 12 his rate, and that's right there. And you get 1.6 miles, okay? Now, here's the thing. For Karen, we know that the total distance that she traveled was 1.8 miles. However, that's from part B. She backtracked and had to go home to get her calculus homework. So that means to know the displacement, we have to integrate just velocity. So when you integrate just velocity, you get 1.4 miles. That's her displacement. That's the change from home to school. So you have to watch out for that. Now, if we're looking at this, we can see that Karen actually lives closer to the school. So hopefully all of that makes sense.